Welcome back. Today's discussion is smoothing. Smoothing is a technique applied to time series to remove fine-grained variation between time steps. But the question is, what is the purpose of smoothing? Let's say we have outliers. You have reason to believe that data needs to be smooth, and truly, if those spikes, for instance, are accurate, they will not reflect the underlying process. That's why it's quite common to smooth our data. Here's the questions you may ask yourself while you're smoothing your data. It can be used for data preparation. Is your raw data unsuitable? Right? You may have some very high values. It can be used for future generation. By smoothing, you're collapsing many dimensions into smaller number, which is especially important in machine learning. You can use it for prediction. You'll be making prediction from a smooth feature. And finally, visualization. You'll see better signal with the smooth data compared to noisy scatter plot. All right, so smoothing is a technique applied to time series to remove fine-grained variation between time steps, right? And we've seen already it can be used to remove some random variation, random noise, and also it's used to show some underlying trends or cyclic components. There are several common types of smoothing technique that can be applied. Moving average smoothing, which is used for short-term fluctuation, and also it's used to highlight some longer-term trends or cycles, especially in data visualization. There's also exponential smoothing, which is weighted moving average, which will be covered later in chapter 8. And there is another type of smoothing, which is a non-parametric technique, locally weighted regression technique that also allow you to smooth your data. Why can't we just use simple average? Here's an example of income data. And if you take a simple average, or mean of all past observations, this is our estimate. But it's only useful if we do not have any trends in our data. So alternative way and a better way to summarize the past data is to compute the mean of much smaller sets of numbers in past data will be moving average. So instead of taking the entire time series and average it out, we'll take much smaller time points and average them. By the way, the moving average was developed in the 20s in the last century, so it's the oldest process for smoothing data, but it's still very popular and very useful. Let's start with moving average for odd numbers. So at each point t at time, we'll determine average of observed value that's around our particular time t. So if our window is of 3, and here's our t time, so we'll take average of observed value that's around this particular t. It is very common to calculate, for example, a 5-year moving average, 10-year moving average, 7-day moving average. For example, let's have a task to calculate 5-year moving average for this sale data. Right? We have years from 2003 up to 2012. So the first step is we'll have a subset of 5 years. So the first subset with a center year of 2005, we'll calculate the average. We'll take all the sales values and divide by 5. So we'll assign the value of 6.4 to 2005. Our second subset will be, it's like sliding window, right? Our next subset of 5 years will be from 2004 to 2008, and the center is 2006. All right, we get our value for that, and we keep going through all subsets until 2010. What's interesting about this type of smoothing is that we are going to have some points missing at the beginning and also at the end. As you notice, we cannot have smoothing center year 2003 or 2004, right? We start with 2005. The same goes with 2011 and 12. And finally, we can visualize our obtained new time series starting from 2005 and up till 2010. What happened if we have even time periods? For instance, in a previous slide, our window was, we were calculating 5-year moving average. So the center was 2005. But what happened if we have even time? So if we take time period January, for instance, monthly time series t equal 1, and then t equal 12 is the last month, the average would be 6.5. So we have a June, July, and the average will be right between these 2 months, so 6.5. So the solution is we'll calculate January up to December, one average, and the second average is the average of February to January with T13, and the average of that. So our T is equal 7. So this is our center, T7, and you notice we have T minus 6 and T plus 6 have only half coefficient. Well, the reason is all the coefficients should sum up to 1. When we work with quarterly time series, you notice we using only half weight. And the same with the monthly. Moving average can be one-sided and two-sided. So one-sided moving average will include the current, here's the current, and the previous observation. For instance, x t minus 6, minus 5, etc. up till x t. Two-sided method, two-sided centered moving average include previous and future observation for our time t. The difference between the centered moving average and weighted moving average is just the weight coefficients. Two-sided methods used for smoothing time series to highlight underlying trends. Exponential smoothing is another technique which uses exponential window function. So the greater weight will be placed to the recent values, observation, next to the t time, and the lesser weight will be placed to the older observations. And to do that, we apply the recursive function where the alpha is multiplied to recursively to the previous value. And on the right, this is an example of various alphas as compared to the actual time series line. So smoothing helps us remove noise and expose our signal. We've seen it in moving average smoothing. We assign equal weight to each observation. In exponential smoothing, we're assigning a different weight. So the closer time was to observed value, the more weight it was given to more recent values compared to the older values. We've also seen that moving average require window size, so we have to specify what is our length. Now, if there is a seasonal pattern in your data, you should set your moving average equal to that length. But if there's no seasonal pattern, you can choose a length that makes sense to you. And of course, the longer size or the length is going to be, the smoother our lines are. We also learned that one-sided is used for forecasting and two-sided method is used for smoothing.